I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, October 16th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure to hit the like and subscribe button. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale still producing 15-foot seas in the northwestern Gulf of Alaska aimed off to the east. We're seeing the beginnings of yet a new gale starting to develop northwest of Hawaii and moving off to the east pretty quick. Let's get into the details. As usual, we start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, that is a push in the jet to the south. We see a little bit of it right there, a little bit of it right there. What that helps do is create a counterclockwise flow aloft and also down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they eventually radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. Right, so we have sort of the start of a trough here, somewhere over the North Dateline region, and remnants of a previous trough pretty much cut off and no longer in existence here in the, call it the Central Gulf. But the good news is the jet is no longer way off to the north. It's sitting about where it should be for this time of year, right around 43 north, something like that, and that's good news. That then helps manifest just like this come Monday, another trough forecast building being fed with 150, almost 160 knot winds. They're ridging up over the Kuril Islands, but then those winds start falling, carving out this trough on Monday, and that trough getting pretty well defined as we get into Tuesday with winds of 170 knots, almost 180 knots feeding into it. That should certainly help get some circulation going. But then as we get into Wednesday, the trough gets extremely pinched off. That tiny little area there, you need a broader dip in the jet to really allow a good gale to get going. So whatever does form, well, you can see it there, it literally gets cut off completely, and you end up with this what they call a cut-off low. It's cut off from the main jet stream flows. You see winds up here, 200 knots, and they're just south of the Aleutian Islands. But this low cut off still might help support low pressure development north of the Hawaiian Islands. And then as we get into Friday, the 21st of October, look at this, the jet starts lifting back to the north, not looking so good, getting kind of weak over here in the far west Pacific, almost looking like it wants to split. And does it do that? Well, it looks like it is supposed to split come Sunday, next weekend. We'll see. But the expectation is winds should start rebuilding off to the west, and this should be a temporary setback. Next up, surface level pressure, surface level winds. Remnants of a gale. You can see the isobars from low pressure fading here in the northeastern Gulf. But a new low starting to develop on the South Dateline region, already producing 35 to 40 knot west winds, targeting sidebed energy at Hawaii, and then forecast to quickly push off to the east and start building on Monday. That'd be the 17th of October, with a good fetch of 40 knot winds aimed somewhat at the U.S. West Coast, and then winds wrapping around the core of the low aimed back from the north down at Hawaii. And that low building pretty good as we get into Tuesday with 55 knot west winds forecast. That would be pretty good if it were to happen. Aimed mainly Pacific Northwest in Canada, but maybe down, some swell could result as far down as maybe Point Conception. And then look at this, high pressure and north winds building off the backside of that as well, targeting Hawaii. The low continues a little bit into Wednesday, but starts fading. We know there's a cutoff trough or cutoff low forecast to develop on Wednesday, and here it comes, building. Let's go back just a frame or two here. There we go. 40 knot winds aimed at the Hawaiian Islands, maybe 45 knots, so some swell for the Hawaiian Islands from that. And then another little low, this is new on the charts, forecast for Friday, so about 5 days from now. pushing over or just south of the eastern Aleutians, maybe some swell from that, and then into the northern Gulf. Also notice a bit of wind here along the California coast. We'll get into that in a minute. And then another low forecast off Kamchatka as we get into Sunday, but pretty much pushing north of the western Aleutians and of no real interest. So at least there's something on the chart now, and it looks like fall is finally starting. So let's go back in time just a little bit. A gale started developing on Thursday. This is 2 or 3 days ago, off of Kamchatka, 20-foot seas, something like that, 21.3 feet to be exact on Thursday evening. These are the highest seas over this entire domain, but you do need to check the coordinates to make sure it's this fetch and not some other fetch that's all landlocked and somewhere not capable of producing surf. Anyway, you can see the fetch pushed well to the southeast, swell, and with seas in the 21, maybe barely 22-foot range, and then the gale faded out on Saturday night. That would be last night. Swell from this system approaching the Hawaiian Islands, also bound for the U.S. West Coast. Bigger size for Hawaii, nothing huge, and mainly this is going to be isolated to Point Conception northward, but think of the California, generally like 4 feet at 13 seconds or something like that. Nothing huge, but something rideable. Next system then starts developing. Let's go take a look at that. Here's today's image. That was all hindcast data you saw before. Actual wind creating seas, more or less confirmed on the ocean surface. But this next one, supposed to be a little bit more energetic, sort of a little blast of 20-foot seas aimed at the Hawaiian Islands. Then the thing starts wrapping up Monday night into Tuesday morning in the, we'll call it the northern Gulf, with 33-foot seas aimed mainly at the U.S. West Coast, and then building with 41-foot seas later on Tuesday. Look at the little arrow, and you kind of know what the winds are doing here. They're out of the west, so swell somewhere pretty good size probably in this area right here to result. And then you can see all the fetch starts really taking aim at northern Canada, not at the U.S. West Coast. But a little bit of secondary fetch develops behind that from that cutoff low that we were talking about earlier. This would be on Wednesday, October 19th, with 24-foot seas over a small area aimed south of the Hawaiian Islands, maybe building to close to 25 feet, 25.8 feet to be exact, aimed directly at Hawaii and all of about so that's about 6, maybe 700 nautical miles north of the island. So probably a good little blast of swell from that. Local, a little bit raw for Hawaii, but any surf is better than no surf. Then we get into the weekend. We know another little gale is theoretically forecast south of the Aleutian Islands, pushing off to the east pretty quick, maybe making some swell for the U.S. West Coast, and then that final low pushing up into the Bering Sea and likely of no interest. With all that said, in the north, we still look to the south because a small gale developed on Tuesday, October 11th, and seas in the 26-foot range, something like that. It's producing background swell that's hitting as we speak. And then another gale developed starting on Friday, the 14th of October, with 31-foot seas. Now, kind of late in the season, but pushing well off to the northeast. Swell from this system is going to be generated. A little sideband energy for Hawaii. The main event, though, to be California, mainly Southern California, Northern California, if local winds do not mar the situation. And we'll get into that in a minute. Looking forward for the southern hemi, that's pretty much it. We're into Tuesday. A little tiny gale, maybe forecast with 28-foot seas, aimed more east than off to the northeast. The low itself is almost falling southeast, but not quite. Maybe another little bit of fetch off of New Zealand, seas 26 feet. But as the North Pacific becomes more active, whatever swell does result will probably be buried under either local wind swell or swell generated in the Gulf of Alaska or off in the dateline, and not so much of a swell producer anymore. Local wind forecast, Hawaii down here, California right here, low pressure off the coast, creating south winds, not strong, just off the coast. But what that has done is sort of kept this perpetual moisture machine going, circulation like this, and what it results is thick fog along the central and northern California coast. That's been the case for seems like a week now. Theoretically, that's going to continue a little bit longer. Here comes our big low up in the Gulf of Alaska. We're not really looking at that. We're just looking at local winds, a light local wind flow. This is Tuesday, October 18th, pretty much the same for Hawaii. As we get into Wednesday, same deal. Here's that cutoff low forecast north of Hawaii beginning on Thursday, aimed right at the islands. Also, though, winds out of the northeast trades might make things pretty marginal on exposed north-facing shores. Also, high pressure starts building here in the eastern Gulf, setting up some fetch over northern California. And look at this. Look at the low, really close to Hawaii, likely having some impact on winds there, and high pressure doing the same thing for California as we get into Friday. Now notice, winds not too bad immediately along the coast except up at Cape Mendocino, 30 knots out of the north. That'll start generating wind swell. Low pressure very close to the Hawaiian Islands, almost setting up south winds it looks like. And then as we get into Saturday, the wind machine driven by high pressure starts to impact California, and the low north of Hawaii starts to clear out. On Sunday, 30-knot north winds along all of central and north California coast. What a mess. Light winds for the Hawaiian Islands. And then we're a week out. Winds continue for California. So the timing of swell arrivals and generation of wind over the weekend is something to be a little bit concerned about. Time your sessions accordingly. Since it is middle of October, that's typically when we see the first rainfall. Of course, we already had one rainfall here in north and central California. Was that 2 or 3 weeks? 3 weeks ago, something like that. Very early. Typically, it's between about October 15th and October 30th when we start to see the first semi-legit rainfall pushing into, say, the San Francisco Bay Area. Right now, everything looks high and dry, high pressure in control, but there is this backdoor front that's hinted at next weekend. It doesn't look, well, there you go. You see a little bit of snow forecast for maybe Tahoe and the Central Sierra, maybe, but it's a quick mover, pretty much 6 or 12 hours, and it's out of there, and then back to a high pressure regime. Here's the snow forecast dashboard for Tioga Pass Road, where it intersects with the Pacific Crest Trail. That's at about 9,600 feet. You see just the hint of maybe a ½ inch of snow associated with that backdoor front we were talking about. Looking at snow levels, freezing level 12,000 feet right now. And then on the 23rd of October, theoretically, snow levels falling to 6,000, maybe even 5,500 feet. This morning's run of the model didn't show any of this. It had it going down to maybe 9,000 feet. So suspect this is a little overhyped. And then as soon as that one-day front plows through, then we're back with snow levels up about 11,000 feet, something like that. So we're not really in a position yet to start declaring that either significant rainfall is going to fall or significant snowfall, but at least it is a baby step in the right direction. All right, let's look further out. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? We start by looking for signs of the active phase of the MJO. The MJO, the Madden Julian Oscillation, is this periodic weather oscillation, rotates around the planet from west to east on the equator. Active phase on one side of the planet, inactive phase on the other. They rotate around. The active phase is effectively a low pressure system. When it is over the Pacific, it creates clouds, it dampens trade winds wherever on the equator it is. It also imparts energy to the jet stream, and that in turn activates the jet stream and helps create storms, which therefore generate waves. High pressure does the exact opposite, pretty much steals energy from the jet stream and shuts down the storm track. All right, so we're looking for signs of the active phase of the MJO. This is data from the TAO buoy array, series of buoys strung across the equator in the Pacific from west to east. This is the equator here. This is the West Pacific. That's New Guinea there. East Pacific here. All right, and Ecuador would be sort of off the edge of the picture here at about 80 west, something like that. We're looking at arrows. This is data from the buoys. There are wind direction sensors and wind speed sensors on those buoys. The longer the arrows, the stronger the wind. So strong east winds in the East Pacific, strong east winds in the Central Pacific, strong east winds in the Kelvin wave generation area, the West Pacific. That area from 170 west, so almost to the date line, the whole way over to the far reaches of the West Pacific, 135 east, right in here. And that is where, when the active phase moves over this area, the Kelvin wave generation area, it not only imparts energy to the jet stream, but can also take warm water that's normally positioned over here, start pushing it off to the east, underneath the equator in the form of a Kelvin wave. If you have successive active phases of the MJO, which generate successive Kelvin waves, that can usher in El Nino. What that does is just take warm water that's normally here and starts pushing the balance of it over to the East Pacific, where typically there's an upwelling pattern, like driven by these easterly winds, and starts warming it up, and then that drives the jet stream nuts in a good way for California in terms of both surf and for precipitation. Now, it's not the actual wind speeds that matter so much, it's the anomalies, the differences from normal for this time of year. So yeah, the wind's pretty strong out of the east over here, but looking at these arrows there, just a little bit stronger than normal for this time of year. Looking in the Central Pacific, definitely winds are modestly stronger than normal and moderately stronger than normal over in the west in the Kelvin wave generation area. So that smells of the inactive phase of the MJO. Looking at 850 millibar zonal wind anomalies for the past 5 days. These are winds up at 850 millibars. That's up in the atmosphere. The surface is down around 950 millibars, something like that. So this is up about 4,700 feet. But let's get ourselves oriented here. South America, Central America, the Philippines, New Guinea right there, the equator right there, dateline right there. The important area we're looking at is the Kelvin wave generation area right in here. The blues, and you just look at the arrows, they're out of the east. This means winds are stronger than normal out of the east, which would suggest the inactive phase of the MJO on October 10th. Same deal on the 11th. Same day on the 12th, but notice westerly anomalies starting to build over the maritime continent. And the same deal on October 13th. And on the 14th, you get the sense westerly anomalies are trying to make a little bit of headway into the Kelvin wave generation area. That would be a good thing. Here's the 850 millibar zonal wind anomaly forecast for the next week. What we saw before was just what's been happening the past 5 days. Here's what's supposed to happen the next 7 days. And this is the whole planet on one chart. Blues are easterly anomalies, yellows and reds westerly anomalies. So the blues are like the inactive phase of the MJO, or if they're prolonged long enough, and you can see it's completely off the chart here, that means the La Nina. And the westerly anomalies typically are the active phase of the MJO, or if they're stuck in one place long enough, that would typically be well, in this case, they're over the maritime continent. That would be a La Nina sign as well. Let's get ourselves oriented. This is the whole planet on one chart. The date line runs right up the middle, the international date line. Kelvin wave generation area, i.e. the far west Pacific, charts about 135 east. So you can take that right up the chart. So you can see the Kelvin wave generation area has been pretty much locked down by high pressure and easterly anomalies for months now, driven by La Nina, of course. But notice 4 to 5 days from now, those easterly anomalies, which are pretty strong right now, all of a sudden start to fade. You see westerly anomalies that have been locked at 90 east for months, maybe starting to slide off to the east and into the Pacific a little bit. That, we are hoping, is the beginning of the end of La Nina. And it's only a week away. Not trying to hype it too much, but theoretically, we could be moving into a much better place. Let's dig deeper into that thesis. All right, let's go out 2 weeks. All right, and we're looking at, this is a model for outgoing long wave radiation. Cloud cover, basically. All right, South America here, Central America here, Hawaii, New Guinea, the Philippines, the equator right across there. Date line right up there, 180 west. Kelvin wave generation area right here. The blues are where there is more cloud cover. The active phase of the MJO is like a low pressure system. Low pressure systems generate clouds. The reds and yellows are areas where there are no clouds forecast, and that typically is associated with high pressure, the inactive phase of the MJO. So, according to this, looks like the active phase of the MJO is starting to build over the West Pacific. This is the statistic model. It suggests it holding 5 days out, starting to weaken 10 days out, and then be gone 2 weeks from now. Now, the dynamic model paints a little bit different picture. It suggests the active phase holding over the Kelvin wave generation area for the next 2 weeks, with the inactive phase holding over the Indian Ocean. This is our preferred outcome. You can see the difference here. Statistic model, last frame. Dynamic model, last frame. Clouds, right where we want them to be. So then we dig a little bit deeper. Same two models, statistic model here, dynamic model here. These are called phase diagrams. They just help us drill in a little bit better to see exactly what's happening. The MJO moves from west to east, from the Indian Ocean to the Maritime Continent. That's a bit like Bali. Over the West Pacific to the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. So this chart maps that out. You can see past history where it's been. The heavy dot is where it is today. The further the dot is away from this circle, the stronger the active phase of the MJO is today. So the active phase is, we'll say, modestly strong, entering the West Pacific right now. The forecast, there's 1, 2, 3 different colored lines from the statistic model, all have the MJO getting steadily weaker over the West Pacific over the next 4 days, and while moving off to the east and somewhere in the Atlantic, we'll say mid-Atlantic, 2 weeks from now. Now the dynamic model, you can see where the active phase has been. You can follow the lines here, and these are the dates, the 11th, 12th, 13th, 14th of October. Today, here's where it is. And it, too, shows the active phase getting weaker, 1, 2, 3, 4, 5. But you see it, instead of crashing, moving off to the Atlantic, it kind of just noodles around in the West Pacific. That's why the dynamic model suggests the active phase holding over the West Pacific, where the statistic model has it just vaporizing and disappearing completely. So 2 different outcomes from 2 different models. Next up, the upper level model. This is a statistic model showing areas favorable for precipitation. The greens, areas favorable for precipitation. One would assume that's the active phase of the MJO. The yellows and oranges, dry air, typically the inactive phase. And let's get ourselves oriented. South America, Central America, New Guinea, the Philippines, right there, 0, that's the equator. Date line roughly here. Kelvin wave generation area right here. So each one of these frames is 5 days into the future. So you can see wet air, the active phase of the MJO, making its way across the Pacific and into Ecuador, roughly about November 10th, something like that. Then the inactive phase trying to get set up right after Halloween, making its way across the Pacific, but pretty weak, with yet another active phase, weak, building in after that. So you can sort of see that if I were to make guesses about when surf would be good, I would say pretty much the whole month of October looks like a pretty good bet. October, not so much. November, not so much, until you get to about the Thanksgiving time frame, and then maybe things waking up. Next up, the GFS forecast for east and west anomalies, zonal wind anomalies, across the Equatorial Pacific. So you can see Mexico right here, little piece of maybe the Ecuador or the Galapagos right there, the equator right there. Kelvin wave generation area, 5 degrees north to 5 degrees south, out to about 170 west right here. The blues are easterly anomalies, inactive phase of the MJO. Oranges and yellows, westerly anomalies. We want to see these developing over here, all right? But the fact that they exist at all in the Pacific on the equator is already good news. We're going to put this into motion, see how this goes. You see westerly anomalies trying to make some headway here into the Kelvin wave generation area, and you see easterly anomalies dissipate. We're out Saturday next week, and all of a sudden things are starting to look much better. You go, hey, we're in there. Look at that, westerly anomalies starting to build. Then watch this. Right when we think we're in the money, easterly anomalies start redeveloping about October 25th, something like that. And they sort of pulse, but not as strong as they've been. And then westerly anomalies really start setting up, there we go, as we get into the end of October and beginning part of November. And we think this might be the beginning of a trend in the right direction. So then we look at the CFS model going out a month, from October 14th out to November 11th. Again, same deal, whole planet on one chart, date line running right up the middle. Blues are easterly anomalies. You just eyeball this and go, God, looks like a La Nina holding the whole way through. Westerly anomalies here over the maritime continent. Kelvin wave generation area roughly in this box, something like that. Now the solid black contour is the active phase of the MJO, and you see, so in each one of these tick marks is a week. So in about 3 or 4 days, active phase starts making its way across the Kelvin wave generation area. Westerly anomalies pretty much track the whole way across the Pacific. First time in months we've seen that. But then right after that, easterly anomalies redeveloped. Now this is where things get a little bit dicey. This image not looking so favorable, especially down in here towards late October and early November. But another model shows of the same model, the CFS, a same model, just a different depiction of it, shows a different pattern. So here's that other model, the CFS model, 850 millibar zonal wind anomalies. Let's get ourselves oriented. Now, the forecast is up top. What's happened in the past is down here. The date line runs right up the middle. Kelvin wave generation area, well, the far west Pacific starts about 135 east. So this area here is what we're interested. The blues, easterly anomalies, the yellows and oranges, westerly anomalies. So right now, you see pretty strong easterly anomalies over the date line. You see what appears to be the active phase of the MJO trying to move into the Kelvin wave generation area. About 4 days from now, westerly anomalies sneak the whole way across the Kelvin wave generation area. That's a first. Well, we kind of see something sort of looks like that there, and even weaker there. But again, another little pulse of that. But what's really interesting is notice the easterly anomalies here. And we're not talking way off in the future. We're talking a week and a half, 2 weeks at the most. They start pulling away from the West Pacific and start becoming more confined right off the California coast and right over California. And by the time you get to December, almost all but gone. But what's even more interesting, see the white and the yellows? This is all like the white, you can't see it down here, but it's pretty much neutral anomalies. They make steady eastward progress with western anomalies, basically filling the Kelvin wave generation area and then the entire Pacific as we get into the Christmas time frame. Even at, where are we? Even when we get to Thanksgiving, easterly anomalies are gone. And they're really nearly almost gone as we get into the end of the first week of November. This would be a significant change. And now what's even more interesting, you look down here, this is the maritime continent where westerly anomalies have been locked for 2.5 years now. Look what starts happening as we get to mid-December. Easterly anomalies set up where previously the active phase of the MJO and the El Nino signal used to be located. Now the La Nina signal, which has been over the central Pacific, starts reestablishing itself over the maritime continent. And the low pressure bias, or the El Nino signal, starts moving into the Pacific. If this were to happen, a significant change in our weather patterns would set up. The jet stream, fueled by these westerly anomalies, would start building over the Pacific. We'd get more storms, we'd get more rain. You know the drill. Something to keep our eyes on. Okay, so that's all speculation. Let's overlay the MJO just to see. So here's our current weak MJO, the solid red contour here, making its way across the Pacific. And by about, not even a week from now, it's centered right over the Kelvin wave generation area. And then look what it does. It stalls right over the date line and just sits there for the foreseeable future. And yes, the high pressure bias tries to build into the Pacific, but just can't do anything. It tries again even as we get into late December and January, but still does nothing. Westerly anomalies prevail. What is going on? Let's overlay the low pass filter here. This really tells the story. All right, so again, date line right up the middle, the forecast at the top part of the chart. This dotted contour is a high pressure bias. You can just assume that to be the La Nina indicator with two contour lines right now today. But notice as we get into December, the second contour line fails. And then as we get into the Christmas time frame and New Year's, the first contour line completely dissipates. And then also notice this solid contour here, this is the low pressure bias that has been locked over the maritime continent at like 90 east for 2 years now. The leading edge of it starts to ease off into the Pacific. If that happens, then we're in the money. And this is now suggesting, well, yeah, I can take, I did this earlier. It's kind of hard to do it here, but I actually went and queued it all up, and it makes it to about 140, 145 east, something like that. So that's about a third of the way into the Kelvin wave generation area. That would be a really good thing if that were to happen. That'd pretty much signal the end of La Nina from an atmospheric perspective, and that could happen as early as the first week of January. This is good news. All right, so what's going on in reality? That's a forecast. It's a projection. It's tantalizing, but what's actually happening, we're going to start looking down in the ocean first. More data from the TAO buoy array, the series of buoys strung across the equator used for monitoring El Nino. West Pacific here, East Pacific here. You guys, most of you know the drill. These are the anchor lines on those buoys that are strung the whole way across the equator in very, very deep water. The X's are the sensors on the anchor lines. The sensors relayed subsurface water temperature, and then that gets sent off to a central processing facility. You notice there are big gaps between each of these strings or these anchor lines. So you use a model to try to connect the dots and see if you can get a contiguous picture of temperatures. The point being, with this data, you can monitor the production of Kelvin waves and the balance of warm and cold water in the Pacific. So right now, there is no 29-degree isotherm. This is centigrade data. The 28-degree isotherm, which is very warm water, right about where it was last week, 175 east, something like that. 24-degree isotherm, give or take a couple of degrees, about where it was last week. The 24-degree isotherm, I think this is about where it was last week. It might have been 120. It might be receding just a little bit. But it's not the actual temperatures. Again, it's the anomalies, differences from normal for this time of year. Lots of warm water balled up in the East Pacific. The dividing line between warm water and colder water in the east, the La Nina bubble, if you want to call it that, is right here. What is this? It's 160, so about 155 west, something like that. Pretty much no change from last week. Another model using the same data plus some others, suggesting much warm water balled up in the West Pacific, lined up. There's your dividing line right about 155 west, with cold water in the East Pacific. Hawaii would be north of here somewhere. This is down in the ocean, down 150, 200 meters down in the ocean. So cold water. All we need is the active phase of the MJO, westerly anomalies blowing over the surface to take more warm water, sort of give this a nudge and squeeze that cold water out to the surface. I mean, if a Kelvin wave were to start in motion today, it would still take probably 2 months for all that cold water to get squeezed out and out of there. But we think we might be approaching an opportunity for that to happen, with easterly anomalies forecast to fade and westerly anomalies forecast to start slowly building over the Kelvin wave generation area. We suspect this ball of warm water will be unleashed, and that would signal the end of La Nina. Next, sea surface height data. This is not wave heights. You strip all the waves out, the wind waves, the tides. This chart shows you, is the sphere of the ocean higher or lower than normal? Let's get ourselves oriented here. South America, Central America, Mexico, Hawaii right there. The date line right there. the equator right there, New Guinea there. The reds are positive anomalies. So warm water at depth expands. When it expands, it'll create a bump on the ocean surface. And that's what this is. 5, 10, 15, 20, 25, 30 centimeter anomalies, positive anomalies, suggesting a lot of warm water balled up here. The dividing line between, and here's the negative anomalies, minus 15 centimeters. Cold water contracts. You'll end up with a divot on the ocean surface. And so cold water here off of the Galapagos and Ecuador. The dividing line between the two of them, right about there, about 155 west, something like that. So this just supports what all the other models are suggesting. Upper ocean heat anomalies, this just gives you sort of a time sense of what's been going on. West Pacific here, East Pacific here, blues cold water, oranges and reds warm water. You can see very much cold water last year around this time. A Kelvin wave did get generated in December, January. You see the warm water pushing across the Pacific. But then, as we got into spring, more upwelling, more cold water. Another Kelvin wave this summer in the May, June time frame made it halfway across the Pacific or so. And then here's our current pool of cool water. Not as cold as we were up here, but over a large area. There's your dividing line, 155 west. You see much warm water building here, you can see these little nodes or nodules, whatever you want to call them, trying to make their way across the Pacific, but never completely doing it. Looks like this is prime for generating a Kelvin wave. All we need is the active phase of the MJO. So let's go look at the ocean surface, what's going on. And the short answer is not a whole lot has changed. The blues colder than normal temperatures. The reds and yellows warmer than normal. South America there, Central America, Hawaii there, the equator right here. Now last week there was a lot of really cold water here, and the week before that has dampened some. Still, it's there. And all that means is that we know that underneath, where's the dividing line? 155, somewhere like right around here. Down underneath all this is piles of cold water. And then over here, there's lots of warm water. So what's going on deep in the ocean, what's going on at the surface are two different things. But right now, in the East Pacific, the subsurface and the surface waters are locked and cold. The trend for the past 7 days, you can see the reds are warming, and all we're interested in is the equator right in this area right here. You see, water temperatures are warming, but they're still cold in this area. They're just not as cold as they were, and otherwise a pretty, just a neutral pattern in control. The overview showing again the clear La Nina signal, colder than normal water. The official El Nino La Nina monitoring area is from 120 west right here, 5 degrees north and south of the equator, out to 170 west right here. You just look at the water temperatures there and you can measure it. Is it colder or warmer than normal? Just eyeballing it, you can see it's clearly colder than normal. If it's half a degree colder than normal for 5 consecutive months, that's considered La Nina, and that's clearly the case. The Kelvin wave generation area, we pick it up where the Nino 3.4 area ends right here and go off into here. This is where, if you get westerly anomalies here, and driven by the active phase of the MJO, it can kick off a Kelvin wave and set cold water at depth in motion, going underneath and undercutting this whole area of cold water. And once you cut its legs off, it's all over. That's not happening right now, but we're looking for it. Sea surface temperature anomalies in the Nino 1.2 region. This is the area right up there by Ecuador and the Galapagos. Values today, minus 1.983. That's really cold. You can see temperatures have, if anything, the past week, almost 2 weeks have fallen. They've stabilized now, but you really can't go a whole lot lower. So no real hope there. And looking at the official El Nino, the Nino 3.4 monitoring region, temperatures are minus 0.908, 908 thousandths of a degree below normal, falling the past 5 days after kind of spending almost a week or so looking pretty good. Now, not so good, but we'll see. Hopefully, change is coming. So what does the atmosphere think is going on? Well, it probably isn't too hard to guess. If you have cold water over pretty much the entire equatorial Pacific, that supports high pressure aloft because there's no evaporation, and high pressure gets you into La Nina mode for sure. We look at the Southern Oscillation Index, the difference in pressure between Tahiti and Darwin. Tahiti in the Pacific, Darwin over in the Indian Ocean. When pressure is higher than normal over Tahiti, the index is positive. Today's value, 20 positive, or plus 24.3. You can just look down here and see it has been nearly a negative reading for the past month. The 30-day SOI average today at 21.57 and has steadily been rising over the past month, suggestive of the inactive phase of the MJO. The 90-day average, we call this the El Nino La Nina indicator, at 14.43. It too is slowly working its way up, driven all by cold water, easterly anomalies, and all the things that we just hope are coming to a close. Here's the 30-day SOI graphed out. Today we're sitting up around 20 or so. The downward spikes are the active phase of the MJO, the upward spikes are the inactive phase. We were down pretty good there about a month ago, but now you can see we've been slowly creeping up, and we're at about as high as we've been. There's one peak, there's the second peak, here's the third peak for this La Nina. We're hoping that this is the end of it. And what makes us think that? Well, let's take a look. This is raw data from the CFS model for sea surface temperatures in the Nino 3.4 region. All right, so this model updated significantly in the past 4 or 5 days, something like that. And we'll show you here in just a second. So right now, temperature is about 0.8 of a degree below normal. The raw data says as we get into November, and that would be right about there, mid-November, temperatures bottom out at about 1.05 degrees. And there's a steady upward climb. All right, half a degree below normal is the La Nina threshold. You get over that, and you're in neutral territory. This was suggesting that change was not supposed to happen until deep into February. Now with the upgrade of the model, by the end of January, the model's suggesting we'll be out of La Nina territory and heading steadily upward from there, and by July, almost in El Nino territory. Now we don't believe any of that, but this little nudge off of the rising temperatures occurring a bit earlier gives us some hope. Now this is the raw data. The modified PDF corrected version right here suggests the same thing, and even better, suggesting, yeah, maybe the third or fourth week of January we're in neutral territory, whereas a week ago, 2 weeks ago, the model was suggesting, well, maybe it wasn't happening until the mid-February time frame. This gives us hope that the demise of La Nina, if it happens the way this model suggests it could, that maybe we can eke out some sort of a decent winter out of this, but it's all about the timing and how quickly the sea surface temperatures rise in the Nino 3.4 region. All right, so let's wrap this all up. Looking in the immediate future, it looks like there's swell coming, both for Hawaii and the U.S. West Coast from the North Pacific. And on top of that, there's two different swells, a small one and then maybe a larger one, especially for California, and if you're up in Oregon or Pacific Northwest, even bigger there. And then looking down south, one more southern hemi swell on the way, locked and loaded. The issue with that one is when it hits, and I think that's going to be sometime in the weekend, next weekend. North winds look to be an issue in California, and a lot of wind chop, and then even north swell mixed in with that too. So the southern hemi swell, at least up in central California, northern California, could be pretty obscured, if not completely buried, but I'll take that. Big north swell, or even moderate north swell, is better than no swell at all. All right, looking further out, well, the models have upgraded. We're really interested later this week. The consensus model is supposed to update, showing all the El Nino models and what they think is going to happen with regards to El Nino and the demise of La Nina. all those models, the consensus has steadily been that La Nina is going to fade sometime in the February-ish time frame kind of thing. But with the CFS nudging it sooner now, we're hoping the other models will follow suit. That'll give us a little bit more confidence of what's coming. But clearly the CFS model, with its upgrade, is the major thing this week's update of the model was the development of easterly anomalies over in the maritime continent as we get into December. That, if that happens, that certainly would be the demise of La Nina, and that would put us in really good place. But again, we don't trust a model a week out, much less 2 or 3 months out. But fingers are crossed. It looks like the beginning of the change is going to happen somewhere in the next week or two. So we're going to keep watching and going to keep our eyes on it, and we'll talk about it next week when we do the video. Be sure and like and subscribe to the video. Ring the bell. You get automatic notifications when the videos are posted. Links are provided at the top of stormsurf.com, every page on the site, so you can get to the video that way if you don't subscribe. And if you have questions or concerns, please let us know. Write them up. If you're thinking it, 10 other people are as well, and we'll have answers for you, at least our best attempt at it. All right, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching. We'll see you then.